Well, I think what Amir would likes us to do is, I mean, later on we're gonna have we have to create a report out and basically report back to the open QSE panel. And Amir is interested in, as he said early on, in three things. He asks the individual work streams to generate milestones and a prioritized list of, next actions or potential deliverables, and then ideally also some timeline indicating when these can be completed. And I think the challenge now would be, whether we agree on whether we identify such milestones, agree on such milestones, and can note those down for the report out. And the second thing he asks us for is to identify potential overlaps with the other work streams. And the other work streams are software architecture, quantum resource interface, and compiler infrastructure. So I think we have already discussed, now we have not really discussed, but when we talked about quantum error correction system requirements, then I don't know, I guess, there might be some opinions in the room on potential overlap to fault-tolerant compilation. And the quantum resource interface group deals also with integration with HPC schedulers. So I can imagine that workflows we discuss here also have an overlap with HPC schedulers.
So I have an initial thought here. I think a recurring theme throughout this work stream has been that we are not speaking the same language. So maybe a first step to better integrate or overlap with the other work streams is to find areas where we are not speaking the same language and then smooth that out. That's probably, yeah.
Yeah, no, I think that's a really good idea. It's always just hard to figure out, like opening up a blank sheet and like trying to do the vocabulary. But I think that's important. And also we've already seen, like within our own group too, there's also vocabulary ones. And I guess the thing that, I mean, with workflows kind of represents a global, right? Because it brings together a lot of those pieces. And then like what Tom was mentioning is, I mean, basically kind of having a mini co-design community within our own ranks where we have some portfolio applications. We just need something. We need to be able to tell a story, right? And then basically, looking at like the blueprint document and like this is where we're supposed to be in this period of time. These are the sort of applications that they're suggesting. If we have other ideas, of course, but kind of take those and just start running with it. From the workflow perspective, how does it hit the, how does it affect the actual, architecture? How does it hit the actual system software? Because when certain things happen in a workflow, if we don't have the compiler like this or the compiler like that, it causes a problem. Do you know what I mean? It kind of feels like we maybe need to have a couple of globals that kind of tie us all together. So I don't know if that's like a missing working group, or I don't even know if it's a working group, but it's a kind of a crosscut.
So if I understand you correctly, then this would mean that this working group could prioritize or pre-select a couple of exemplary workflows that would then and come up probably already with some high level, at least, system requirements these workflows would demand. Then in the next step, we should, with this output, inform the software architecture working group, schedulers, and with compilers, I'm not so sure.
Yeah. Yeah, I just sorry, I just had a thought. When we talk about personas, the comment that I made before, so kind of tying a few things together. So, like statement one, the blueprint is saying that maybe the first things that we can attack with a certain number of qubits, a logical or logical qubits is quantum chemistry of a certain sort, whatever. Okay. Then statement two, at some point, I was mentioning that there are, for an application go through, there's going to be different interpretations, different needs based on user. So statement three, the idea that we want to hit kind of a threshold mark, early on. So the power users are going to be the first ones having results on an early fault tolerant system with their application. But we want to be able to make sure that once everybody's all excited, then then the kind of, I was like the early adopters, but then kind of like the next phase of people, the next phase of users, they're going to have different requirements for their workflow of the same sort of application that can function on that level of qubits or that level of logical qubits. So what is their workflow? What are their needs? And then are we preparing that environment? Does that make sense? So it's kind of, yeah, it's kind of the immediate need for the power users, what their needs are for that particular workflow that can be, or that particular application, like quantum chemistry, whatever, that can be supported by those level of qubits, logical qubits. And then the next wave of users are going to have a workflow that's going to be different because they're going to need certain things. And so we're kind of systematically knocking back what those are. That would seem something very progressive, or at least getting the check boxes done. So yeah, exactly, kind of user persona based workflows for a particular application set like quantum chemistry that can be achievable with the first wave of early fault tolerant quantum systems that we're going to have. Does that make sense?
Maybe to add to that, I think it'd be nice to, do one of these end-to-end analysis where, you're like, okay, this is exactly like this is a good estimate how much classical compute I need, what are the
Yes.
networking latencies, the decoding, how much decoding hardware I need for this 200 logical qubit chemistry experiment that I can do, and put everything together in like a nice document, and that's what comes.
Yeah, and then and then so just also thinking about the workflow and the behavior needs of like a quantum chemistry. I mean, I'm just kind of curious if we can kind of take one example that kind of it's the same problem, but gets us, kind of different levels of results based on the workflow that we apply to it, right? And then how it goes, because then some users are not going to care. Like I said, sorry, my mind is going faster than my mouth right now. You've got users that are like the power users. They're going to look for certain results certain ways, but then somebody in like the biopharmaceutical area, they're not going to need that level of detail. They're going to need something else, and they're going to need some sort of interfaces and whatnot. And so that result is actually going to be a little bit different, but it's kind of solving the same general area, right? And I kind of feel like going after something specific in quantum chemistry would be really interesting, and this would really support what the blueprint is trying to do too, because then you're going to have these end-to-end workflow designs at a couple of different levels that accounts for the power user, but then the next wave, right? And then with that, you kind of already get an infrastructure set up that you can go once you start getting into the Hubbard models and eventually FOMOCO and all of that. You've got you have your hierarchy starting to be built up in your infrastructure, and then I think also too the what I also want to see, and that also came from the exascale computing report. I remember that they were measuring integration. They brought that into actually their metrics. So, we talk about benchmarking quantum systems and doing this and whatnot. We have all these metrics that are disparate. We also need to kind of figure out a metric suite for that actual end-to-end workflows and what that means. And then if that actually changes based on, parameters of colocality or whatever else.
100%. I think we need better metrics than qubit numbers and fidelities for sure. And yeah.
So for the metrics specifically, we have a lot of integration with resources group. They are already thinking about, having a layer like QDMI or not QRMI for that perfect. No, just the QDMI specifically because they look at some of the telemetry and we can use that telemetry for guiding our metrics that we are talking about, and it also has like a dashboard in QDMI which actually looks at classical telemetry and quantum telemetry, so we can use that, and that goes beyond qubits and 2 qubit gates fidelity. It also looks at, I think, calibration data, so we can make use of T1 T2 times and all sorts of things.
Maybe.
And also about, sorry, just one more thing about the user directed workflows. Don't you think like if two users have the same problem, we will be wasting resources?
What do you mean?
If like two personas are targeting the same problem and there are certain components which kind of overlap, for example, in SQD, you have a circuit like preparation in terms of Hamiltonian encoding or like probability distribution into a circuit, for example. Those are some common components which would be repetitive if we have user-based, workflows.
Well, I mean, I guess what I meant by that is imagine we have the power user, right, who's going to go directly to quantum hardware, deal with it at a very raw level. They may have particular workflows. I mean, this is just a postulate, and I don't stand by it at all. But then you've got another group of users that need a higher abstraction level, for whatever layer they're doing. So basically, what is that? Right. And so you're still, because of the work from the power user, you're still getting results and you're still getting, input and guidance into how, or you're still building stuff that you may build on top of, or it could be different. That part, I don't know. I'm speaking very theoretically right now, but I think it's important that we look at the different user personas and then potentially across the same application workflow. I mean, the thing is, we might be wasting, I don't know, but I don't think we're going to know until we get there.
Maybe I can formalize that thought a little bit in the context of chemistry as you had in mind, right? So imagine that I have some chemistry Hamiltonian, some fermionic system, right? You can be like, oh, maybe an advanced user wants to use a very specific way. They want to encode fermions onto qubits. But maybe someone who's new to the thing is just like, okay, the compiler comes with a default encoding. I'm just going to use that. I don't want to mess with this. Similarly, maybe a pro user wants to choose their own error correcting code. They're like, you know what? I think the default error correcting code on the machine is maybe too bare bones, but I know I have my own error correction code, which I know will perform better. Can I do the concatenation of these things and so on?
As you're just saying that, and now I feel a little bit dumb, as you're just saying that, you're kind of hitting the pattern that we had for the HPC users, actually. I mean, now that I'm thinking about it, because like some wanted kind of clickable interfaces, some wanted, the best that they would do is, use a library, or they wouldn't even get to terminal, to command line. Some would like, alter directives. Some would, go into like full pragma. I mean, so the thing is, you kind of have like different layers, and that kind of represents some of this functional abstraction, right? And so I guess maybe that's kind of where we're going.
Absolutely.
Yeah.
Absolutely. Yeah. And maybe can we make this like a thing, like one of the to-dos from this thing, where at the end we just try to write this nicely in terms of different personas and different black boxes they can open and something different abstractions they want to look
Yeah.
up.
So I think this is a perfect time for us to swap over to the final session. And I was talking to the others here, and here's our thought. So let's, to the readout to the rest of the community, let's bring 3 slides. Let's bring, the first one is the schedule of today for our work stream so that we can remind everybody about what we did. This is kind of what we did throughout the day. Then a second slide that pointed out key observations, right? One example is that it was very clear that we were lacking, even within our own work stream, a common language, for example. And then the following slide is just the actions that resulted from those observations. And I think we can probably keep it pretty short, right? 3 primary observations, 2 or 3 actions. Does that sound reasonable? And we can take those into the weekly meetings to then come up with more specific plans. Okay, Peter, you have your left tap out. Would you be willing to share your screen and maybe drop a Word doc or something? Yes. You agree? Ah, I'm fresh out. Well, okay, so how about this then? What if we start with key observations? Let's give ourselves maybe 5 minutes. We can just, anyone want to throw those out there? We can start writing them down. Yeah.
Yeah, I mean the vocabulary one, and I think, well, not so much this is the vocabulary, but concretely, operational definition of tight integration. Actually, just integration in general. What do we actually mean by that? And then what would we consider tightly integrated versus loosely integrated? And let's keep the latency like as a component of that, but it means more. And so that means, the what were we saying? Similar, networks, similar administrative regimes, policy regimes, basically all of that kind of really super boring stuff that goes, to the attorneys and to the business developers or whatever to hammer out, to sort out. And it's somebody not updating a software package on one side and it being updated on the other side, and it breaks the workflow, that sort of stuff.
From the openQSE point of view, I mean, this is more of a question, and then I will make a comment. I assume we want some sort of unified framework that supports many modalities in roughly homogeneous way, as much as is possible. If that is the case, I think to answer questions of what integration and latencies mean, I think it'll be good to have a modality dependent timescale, right? So for example, when I talk about coherence time of superconducting qubits, we're all thinking microseconds or tens of microseconds. But when I talk about coherence times of trapped ions and neutral atoms, you're thinking maybe a few hundreds of milliseconds or something of that, tens of milliseconds.
Classes?
Yeah. Sorry, go ahead.
Classes of coherent. Yeah,
It's-
and that's a really good, because I mean you also don't want to be like constantly saying, this ion trap or this, whatever, some sort of boundary of classes of.
Exactly. So I'm thinking there is the physical qubit coherence time, where once you specify a modality, you have a range in mind.
So I'd like to jump in just in the interest of time. I think these are the discussions we should have in our meetings, which is great. So, are there any other key observations anyone would like to add to the list that we're going to present to the rest of the community?
How to enable QEC research where it's not hard coded on the FPGA. Like if you want to try your own QEC code, can you? But can a pro user do the same?
Can you sharpen that a bit for me so that I'm not entirely sure I grasp this in practice?
So two things you would need to make happen for that, right? First, you need your fault tolerant compiler to be able to specify exactly how to compile it down from the logical layer to the physical layer. And if the QPU vendor gives you FTQC compiler, well, then you don't have a choice. You're stuck with error correcting code. The second is the choice of your decoder, right? It's also a function, what's a good decoder for a type of error correcting code. And so if it's hard coded on an FPGA and you don't get to play around with the decoder, then you're stuck with whatever's the error correcting code they give you.
Okay, so if I rephrase that, is that we should come to some sort of an opinion or do a survey on what the architecture should look like to support this type of research, given the fact that we're not entirely sure what is going to be the thing?
I think that's one way to put it.
Because in my eyes, openQSE is here to help with standards and recommendations around enabling science in the area, right? So
We can phrase it as a question. Like,
something like that.
how do you build a system where you can do QEC research? Like,
Right. Okay. So we need to better understand the architectures that will support that type of
yes,
research.
and we can make it specific. Like, can you specify the error correcting code in your FTQC compiler? Can you specify the decoding algorithm? Can you specify the hardware that the decoder should be using? Like, do you have these freedoms? And of course, if you had like a very nice heterogeneous architecture, you could do it, with the right networking. But if not, then it's just a thing that's not available to you.
Okay. Thank you. I think we're slowly capturing it. We're getting there. Anyone else? I remember there was an action item earlier, but I'll be honest, I missed my last cup of coffee and I forgot, right? There was an action that we were supposed to take. It was in the back. Someone in the back pointed it out, but I don't think they're sitting there anymore.
I think it was the common language part.
Oh, was that the common language one?
Yeah.
Okay. I thought that one came later.
Also, it's an extension of the common language, and so we have to define what's this workflow. I mean, even the definition of workflow is pretty vague as well. So maybe we can subdivide it by maybe application and workflow. Even we don't know yet we are going to include the error correction as a workflow, right? So is it really workflow, or I think maybe it's underneath the general workflow that the research scientists really needed, so that we can define it something different or something like that. So
Yeah, I think that's a really good point, right? Because I think it was your comment before that you said we were the end-to-end work stream, right? And we have to understand the integration point. So yeah. So Paul, I think that's a solid one there. Is what do we?
I think you were suggesting that we should do it per user, right? Per user persona.
Yeah, I mean, not getting crazy with a ton of them, but a couple of representative user influenced or user driven
Yeah.
workflow for the same sort of application. Is that what we're talking, to kind of see the divergence? That was the whole power user first, and then second wave, and then third wave, because again, for the quantum chemistry, for example, we're thinking that the first wave of early fault tolerant, we could start getting some interesting results.
Right, and for that, my concern was that there might be some overlaps between the actual functionalities that we are implementing per user. So there might be repetition of, wastage of resources possibly. So that's a concern.
I think it's a fair concern. So the way that I see it is, if you look at how we're developing these things, right? Somebody does it on a laptop with very, I don't know, premium access to a device or some sort of set of resources. And then from there, we move to a data collection step, right? And then from there, if we want to share that application with others to repeat it, each one requires a different level of maturity, but it's the same application, it's just a different workflow. Right? So me coding something up, testing a device, checking it out, then me saying, okay, well, I believe that my algorithm makes sense. I'm going to go collect data to see if I can write a paper. And then great, this works out really well. I think other people are going to use it in a module that they then apply for more work. Means that has to be hardened a little further. And that's when that's the way I think about it.
A third point came from Peter. What did you say? Application specific QEC relation. Right. Yeah. So I mean so that one I want to put a pin in, because I think that's that whole that doesn't just I mean, that affects potentially architecture design and location and all that other stuff. So I think that's really a fundamental one.
I'm just bringing Sebastian up to speed. He ran out for a second.
Oh, you have two. Yeah, because I just when it's about common language, right? So I mean, if we need examples, then I think it's like integration or integration tight versus loose, or
Not link workflows
workflows, latency. Yes.
and application. We're gonna like redefine our whole field.
And if I throw one more observation into the ring, I had the impression in the morning that we, you know, people that work on algorithms are obviously super enthusiastic about their algorithms and the algorithmic details, and it's still a challenge to distill the workflow patterns out of these algorithms. So this felt a bit. This did not come easy. I had the impression in the morning. Can somebody confirm or disagree or? Yeah.
I'll confirm that. I think we got excited and ran a little bit down the, what are the specifics of your algorithm and implementation rather than making sure that we focused on the workflow portion of it. For example, and I'm just making this up because I'm not calling anyone out, but what is the accuracy that you're getting out of this? That may not be a workflow question. Okay, so I have an algorithm that I implement, and it goes between the different types of resources in different ways, and we're looking at those patterns, not necessarily whether or not the final result is scientifically relevant.
Or let's say, I mean, I don't know, circuit features, or let's say required features of a QPU versus what is the computational cost to run that, right? Because when you, at least in my simple mind, when you kind of wanna come up with a decent system architecture for a certain workflow, then you have to understand what are the actual components of the workflow. I mean, how much classical compute, how much quantum compute, what's the communication? Exactly. Yeah.
Is bandwidth that do we need to consider that at all? Yeah. Mm-hmm.
Don't forget your point. Don't forget your application specific or application whatever influence.
Sorry.
So how would we wordsmith that into something that?
Yeah, give us the bullet point.
What for the?
What you just said.
I think there is a how to distill workflows from applications point. And
whose screen is that? Is Peter?
Peter.
Okay.
I'm taking.
You're typing, right? Are you casting? Okay.
Sorry. I'm sorry. I'm messing everything up here because I. No, I don't want to do
You're
this.
doing great.
Yeah.
We're all here for you. Go.
I said I mess everything up, not you.
Okay, so Peter, how about we go to the observations one? Let's put our 2 or 3 observations, right? So we're lacking a common language.
That's fine.
And I think you phrased it fairly well, right? Is we're struggling to distinguish between workflows and applications.
Agreed.
Is that right?
Yeah. Because as the people working on the application, you get very excited, but then you may not realize that, oh, these 2 applications you have from the workflow point of view, they're the same.
I mean,
Yeah.
like if we look at the dictionary definition of workflows and applications is what SQD and credit risk analysis is, and workflows is something that goes inside, like how we transfer or communicate between classical and quantum components. So I guess what we are talking about is essentially applications, not really workflows. And workflows are inside that.
Maybe I'd like to add to that. Maybe we have to define workflows, applications, and architectures.
And where does orchestration come in?
That's a good question.
That comes to the common language and in operational definitions of what we're doing here. 'Cause I mean, the thing is, you see orchestration, you see workflow. I mean, all of this stuff kind of gets confuddled. And so I think that, I mean, it sounds crazy, but the thing is, this is not unique to us, this is pick an ecosystem, so that I think is just important. But I do think that this is really important, particularly in our case, just because there's so many pieces coming into all of this and the changing nature of it, that we really do kind of have to get a little bit pingalig, picky with how our usage. Yeah.
Absolutely.
Maybe I had another observation, which I think there was a lot of discussion around QEC requirements, including classical computation, coupling, hardware. I think this is probably what we discussed the most, and so
Yes. Yeah.
understanding that.
How
very
should
well.
we formulate that bullet point? Let's come up with a quick 1 minute.
Hardware, software integration requirements of QEC.
This is the third key
I think
observation.
it's the third key. I think it's big enough to be its own thing.
Yeah. And sorry, would you mind repeating, because I also
Hardware, software, and integration requirements for QEC.
What do you mean, lack of clarity, or?
very nice phrasing. Yes. Resource estimates at the system level. Right.
So funny. I guess I always thought of it that way. No, and honestly, I just realized that I've
Like the
been
aha moment.
thinking of it. Never mind.
I know. Okay, so we're doing great here. Here's my suggestion. We have 10 more minutes. How about we jump to the last slide and come up with 2 actions or 3 actions out of this based on of our key observations.
User persona dependent chemistry workflow, right?
I'm sorry, Mr. Yes.
So for the goals and milestones, we should definitely connect with resource estimation working group and figure out the QEC part of it. For collecting the telemetry, the system requirements, like hardware and software system requirements. So they will be the best people to kind of,
What's the bullet point?
so connect with resource estimation group to outline the hardware and system requirements into a layer, maybe.
No, it's okay. We're formulating. It's formulating. Yeah, it's hard to come up with a concise bullet point. So, I think everyone's thinking here.
Wait, when I think about that for a second, and you had it formulated. So what was yours again?
User persona dependent quantum chemistry workflows.
Yeah.
Yeah.
No, he articulated it well.
And these are the same ones, right? No,
Yeah.
those are
No, this is the same.
these. Oh, okay.
no,
Perfect.
she's a different one, but
Got it.
she's thinking how to formulate
Okay.
it.
Dependent chemistry workflows.
Quantum chemistry.
Thank you. Quantum chemistry workflows, and in the bracket you can write.
We need like scope it or define it, right?
Exactly.
I mean, yeah.
And then in the bracket you can write abstraction layers. No. It's just it's one of the first anticipated applications on a scientifically relevant one, Peter.
It's a time slice, of relevant computing. I mean, that kind of goes back to the blueprint. The idea that with the amount of compute and the quality of compute we should be hitting in 2028, this seems to be the application that we could get a success story out of to show we're on a progress pathway.
Yeah.
I mean, we could take other ones, we could take Hubbard, we could do something with FOMOCO, but the results are going to be just maybe not as impressive or exciting. I think that was the premise. Yeah.
Maybe one more thing in that was that, can you add the end-to-end estimation? Because we also talked about like how much classical compute.
Metric or end-to-end, what are we going to call it? I would say metric, no.
End-to-end resource estimate.
Yeah.
So, sorry, are those the same thing? Should it be end-to-end resource estimate of user persona dependent quantum chemistry workflow? Is that the one bullet
Yes.
point?
Yeah.
Yes.
Okay, great. And then I think to your point, we start there, and if it turns out not to be a good one, yeah, we shouldn't be married to it, right?
Right.
So,
But I think we need to throw some spaghetti on the wall.
somewhere,
We need
yeah.
to start.
so as I understood it, kind of so we realized, okay, we cannot kind of create a complete for the entire application zoo. We cannot come up with system, requirements or a proposal for a system architecture. So what we instead do, we pick one, how you call it, field of applications, and that is, let's say, quantum chemistry. And for the early fault tolerant quantum computing case, we perform this entire exercise of end-to-end user dependent, yada yada yada.
And the thing is, I mean, there's already good use cases out there, right? Tom has one. There's other ones. Peter Coveney has some stuff. And IBM did some great stuff. So I mean, there are these cases. I think we just need to pick, one or two of them in that same class, and then it's always good to pick, folks that are super friendly or teams that are friendly and easy and accessible to work with, right? Because then we can get under the hood of what they're already doing and start, doing that workflow and all of that. So,
And sorry, I saw you grab the mic.
Yeah, I think just want to add one thing. I think we also discussed about the scheduling stuff. Maybe you want to add one of the scheduling. So maybe that might be integrated with the resource manager, right? So how we can add this like a workflow schedulers integrated with the resource manager, right?
Or does that fall under the larger bullet point of, I think you said it, operational terminology that we need to then define and then classify?
yeah. Well, I guess one thing is if we're studying the end-to-end workflow, right, and with the particular problem that's being worked on, if the scheduling component becomes an issue or a factor, then it's kind of subsumed inside that workflow analysis. But or am I
I think
understanding
this is related to also the resource estimation, right? So I think everything goes really nicely, then we can, maximize resource utilization. That's our hope. But I think that's not always happening, right? So, how this resource estimation, starting from resource estimation, and then how we can schedule it, and also we really define, this kind of workflow requires this much resources, and that we can schedule it this way. This might be guideline that we can just suppose things like that.
So we are already addressing that in the other groups because software architecture is kind of focusing on collating all of that and then resource. Yeah.
That's a good.
Exactly.
That's okay.
Yeah.
That's good.
And that's
Overlap, yeah.
exactly. So we should actually make maybe a sub bullet point and exactly make this call out you did, Smriti. So that these are then, these are identified overlaps with the other working
that's
groups. It's
perfect.
about scheduling. It's about sorry, you said it, Smriti. You had a good
Software architecture working group, and then resources and compilers is another working group. So they can actually, resources and compilers could have resource estimation, and software architectures would have the scheduling.
Isn't it resources and interfaces? Compilers is.
Runtime and interfaces is one.
It's resource interfaces. Quantum resource interfaces.
Yeah.
Interfaces. And
They work on the schedulers. Then we have a compiler working group, and then we have the software architecture working group where the runtime discussions.
Yeah. So software architecture then has the scheduling, and then resources and interface.
Resource interface have scheduling. The UNU is they discussed today the latest QRMI paper where they integrated with I don't know a handful of resource managers.
So in the interest of time, sorry, I'm gonna. I'm just gonna so from
so
what
seductive. I'm getting into these topics.
so from what I hear, I think there's two action items, and push back if you feel differently. But I think there is a set of operational terminology that we need to establish, and we can do that in the context of trying to structure this end-to-end workflow, right, in collaboration with the others.
So the thing is, we're doing workflows. Like we do. I guess my thing is we kind of have a overarching in a way, and then we also, I'm kind of what I'm hearing, we also have kind of specific things for clarifying, even the workflow writ large, right?
I agree.
So maybe our job is, I mean, I don't want to like elevate ourselves on a diagram,
Feel free.
but do you know what I mean? It's like maybe it's our job to kind of create kind of target problems, right, with this workflow, and how is it going to hit the schedulers, how is it going to hit the resource managers, how is it going to hit the compiler, all of these things. And so maybe we kind of have these, figure out a couple of things and say, hey guys, we need you to all use this sort of terminology, or can we do this, that sort of thing.
Yes.
And then we've got this workflow where we're, going there. So we're the synergizers and doing it that way. So, and so, so our job is to crosstalk with the other groups too.
Yep. Great. You can repeat that in
I
2 minutes.
will. Okay.
Identify requirements we pass on, but on the other hand, we also ask them
Mhm.
their they think
Their feedback and their whatnot, yeah. So I mean, the thing is, I don't want to say like introvert extrovert, but maybe we're the social ones that we're constantly going back and forth and making sure that we're getting that information for them, and then reporting it out back to them of how it all works together with the workflow.
Maybe instead of sharing requirements, gather requirements.
Gather, yeah.
Gather requirements and feedback.
Gather and share.
Share.
Quick,
Requirements.
type, because if you finish this in 50 seconds, we're on time. Okay, so if everybody is, should we remove the last bullet point? Is that a, right? I think it's captured in the others. Yeah. Yeah. Okay, so going once, going twice. Anybody have a last comment, question, concern, or modification they want to make to these 3 slides? If not, thank you, everybody. This has been great.
Way to keep us on time. Very good.
Thank you, everybody. This is a great job.